Hello, everyone. Miss Richards here to teach you today about multiplying and dividing with exponents. I hope you are all staying safe and healthy at home and keeping yourselves sane. And we will continue our journey here with online learning. So today we're going to start with multiplying with exponents, and I'm going to go ahead and make this larger for you to be able to see it. And what I'd love for you to do is copy down the examples that I'm writing here so that it can help you out with the assignment at the end. To begin with, to multiply with exponents, what this really means, 5 to the third power times 5 to the second power. Remember, 5 to the third power really means 5 times 5 times 5 3 times. And 5 to the second power means 5 times 5, only 2 times. And since we're timesing in the middle there, we're really multiplying 5 by itself here 5 separate times. So the answer to that would be 5 to the fifth power. The shortcut here that you may remember that we did at the beginning of the year is if we have the same base number and our exponents are different, what we can do is keep that base number for our answer of 5 and then add the exponents 5 and 2 to get to the fifth power. Down here is really the work. This will hold true all the way through our multiplying with exponents here. So even if we have a negative, it's really the same process. That means negative 5 times itself 3 times here, and negative 5 times itself 2 times here, meaning that we have 1, 2, 3, 4, 5 negative 5s multiplied by themselves, giving us negative 5 to the fifth power. And again, you can use the shortcut since the bases are the same, keeping that negative 5, and add our exponents of 3 and 2 to get 5. Now, something important to point out here is that there's a parenthesis around this one, and the reason is because it's holding the negative there. Without those parentheses, you're really saying 5 times 5 times 5 times 5 times 5, and then putting the negative on in the end. But this way it's saying negative 5 times negative 5 times negative 5, so that we know that we can include that because we know that a negative times a negative will give us a positive. And so we want to make sure those parentheses stay on when we have a negative base. Okay, moving on to example 3. And now you're probably remembering and catching on. It is the same concept when we have a variable. For example, x to the ninth really means x multiplied by itself 9 times, and then times the same base, x, to the fifth. So we can keep that same base of x, and we can simply add the two exponents. 9 plus 5 is 14. So this is the final answer, and that's without writing everything out every time. And that's the basics for multiplying with exponents. Now, where it gets a little bit more challenging, I will say, is in example 4. So in example 4, we're still multiplying, and technically there's a multiply sign in between the 5 and the x to the third, and another multiply sign between the 3 and the x to the fourth. The difference is 5 and 3 are different bases, but we have a matching base of x. So in the event that you have different bases and you're multiplying, what you do is you multiply the two bases that are not alike. So we're going to multiply 5 times 3 to get 15. We get to use our same concept that we used in the first 3 examples for the matching base of x. So x to the third times x to the fourth is, again, we're going to add these exponents, get x to the seventh. So we end up with the answer of 15, x to the seventh. So multiplication is relatively easy. When your base is the same, you can add the exponents. When the bases are different, you want to multiply those and only add the exponents on the same base. Now, moving on to dividing with exponents. It is a similar concept. Division, remember, in algebra, a lot of times we write division as a fraction. So this fraction really means we're dividing. But what we have here, 6 to the fourth power, again, it means 6 times 6 times 6 times 6, 4 times on our numerator. And in the denominator, we have 6 squared. So we have 6 times 6, only 2 times. Now, if you are familiar with a fraction that has the same top and bottom, you know that that equals 1. And you also know that multiplying by 1 will give the same answer. So essentially, we're multiplying by 1 right here, so we can cancel that out. And we have another set that we can also cancel out, leaving us with only 2 6s multiplied by each other in the top. So our final answer is 6 to the second power. What's the shortcut here? Well, we had the same base on the top and the bottom, on the numerator and the denominator. And what we ended up doing with our exponents, 4 and 2, is we subtracted them. So really, we kept our base of 6, and 4 minus 2 is how we get 2. That's how we do it without writing everything out. Okay, so the last example that I'll go over with you today is dividing when we have variables in the numerator and denominator. Well, the variable happens to be the same again, so we get to keep that base of x, and since we are dividing here, what that means is we're going to then subtract the 7 and the 3. So 7 minus 3 gives us 4. And that's our final answer, is x to the fourth. If you wanted to show the work or you were unsure, the numerator would be x multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. And the denominator is x multiplied by itself 3 times. And so you get 1, 2, 3 sets to cancel out, again leaving you with 4 x's on the top, which is how I got x to the fourth power without doing the work. Okay, so hopefully this is helpful for you in completing your online assignment today. It is on the third slide, and you can type your answers right into that slide. It should save automatically, and once you get done typing those in, what you want to do is go back to the Google Classroom and click the Turn In button, which is in the upper right-hand corner of your screen. If you have any questions, please feel free to email me. Or if you have Mr. Caterino or Mr. Ricketson or Mr. Conway, they're on email too every day from 10 to 2. Some of us will answer emails at night too, or the next day if you need it. Good luck, and we miss you, and hopefully this was a nice, easy lesson as a reminder. See you soon.